What if you could literally see the future of your money? Well, today we're going to do just that. We're breaking down a super powerful financial idea called the time value of money. Stick around and I'll show you exactly how to figure out what an investment today will be worth years down the road. Let's get into it. So let's just kick things off with a simple question. Is $10,000 in your hand right now worth the same as someone promising you that same $10,000, but you gotta wait 20 years to get it? I think deep down we all know the answer is a big no way. But the real questions are why not? And by how much does that value actually change? That's what we're here to figure out. And here's our roadmap. First, we'll get into the why behind money's changing value. Then, I'll introduce you to the tools for what I like to call financial time travel. We'll see them in action with a simple bonus and then with a huge corporate investment. We'll even compare the old school math to modern spreadsheets. And then wrap it all up by showing you how this gives you some serious power over your financial planning. Okay, so why isn't 10 grand today the same as 10 grand in the future? The answer is this almost magical force in finance, and it's called compound interest. The best way to think about compound interest is like a snowball rolling down a really big hill. It starts out small, right? That's your initial investment. But as it rolls, it picks up more snow. That's your interest. And here's the cool part. The next time it rolls around, it's not just gathering snow on the original little snowball. It's gathering snow on all the new snow it just picked up. It gets bigger and it gets bigger faster. And that, my friends, is the magic of earning interest on your interest. So, to actually calculate the effect of this giant financial snowball, the pros use these special tools called single amount factors. You can just think of them as the engines for our own little financial time machine. First up, we've got P for present worth. This is your starting point. It's that one lump sum of cash you have right now at what we call time zero. It's the seed you're planting today. And on the other side, you have F for future worth. This is the lump sum you'll have at some specific point down the road. It's the big tree that grows from that little seed after a certain number of years. And usually our whole goal is to figure out either P or F. So how do we actually travel between the present and the future? Well, we use these two key formulas. If you've got money now and you want to peek into its future, you use the F/P factor. That moves you forward in time. But if you know you're getting a chunk of money in the future and want to know what it's worth today, you use the P/F factor to travel backward. It really is that straightforward. Now, you might see finance people use this kind of nerdy-looking shorthand, something like F/P 8% 20. It looks complicated, but it's just a quick way of saying, I want to find the future value, given the present value, at an 8% interest rate for 20 years. See? It's just a simple code to make the calculations way faster. All right, enough with the theory. Let's make this stuff real. We're going to start with a simple, totally relatable example about an engineer from our source material named Sandy and her year-end bonus. Time to put that Fashpack factor to the test. Okay, so here's the deal. Sandy gets a $10,000 bonus. Awesome. She invests it right away, and she's expecting to get about 8% per year on it. Her goal is to use that money in exactly 20 years for a massive family vacation. The big question is, how much money is she actually going to have? So our P is 10 grand, our interest rate I is 8%, and our time N is 20 years. Solving this is just a simple three-step process. First, we write down everything we know. Second, we pick our tool. And since we're looking into the future, we're going to grab that FP formula. And finally, we just plug in the numbers and let the calculator do its thing. And what do we get? Sandy's $10,000 bonus is going to grow to over $46,000. Now that is the difference between a pretty nice vacation and a truly unforgettable one, all thanks to a little patience and the power of compound interest. The key takeaway here is this. $10,000 today is financially the same as, or equivalent to, $46,610 in 20 years as long as that 8% interest rate holds. Okay, so that was personal finance. But what's so incredible is that these exact same principles scale up to gigantic multi-million-dollar corporate decisions. So let's level up and check out the Hardy Steel case to see how this works on a massive scale. So here's the scenario. Hardy Steel is planning to build a new plant, and the price tag is a cool $200 million. They plan to build it in the year 2020, and for all their financial planning, they figured their cost of money, you can think of that as their interest rate, is 10% a year. So here's the problem laid out on a timeline. We have that planned $200 million investment right there in 2020. We'll call that our present for this problem. But the company's board has two big questions. First, what would this have cost if we'd done it 4 years earlier, back in 2016? And second, what happens to the cost if we push it back 3 years to 2023? Let's tackle that delay first. If construction gets pushed from 2020 to 2023, what's the real financial hit? This is a classic find F given P problem, just with a lot more zeros at the end. When we run the numbers with that same F&P factor, the cost skyrockets from $200 million to over $266 million. A 3-year delay makes the project cost over 33% more. For a board of directors, that is a gigantic, absolutely critical piece of information that they got from one simple, elegant formula. Now, for decades, engineers and analysts had to crunch these numbers by hand or with these huge books of tables. But, we live in the future now. We have much better tools. So let's compare that manual formula to the modern way of doing things with a program like Excel. Check this out. On the left, you see the old way, the manual calculation. On the right, you see how you do it in Excel. To find that future cost, you just use the future value, or FV function. And look, you get the exact same answer, $266.2 million. Same thing for looking backwards in time. The old formula uses that tricky negative exponent, but Excel just has a present value function, and boom, same $136.6 million. This is exactly why spreadsheets are so powerful. They make these crucial calculations instant and pretty much foolproof. All right, let's bring it all home and wrap this up. We're going to summarize the powerful new tools you've just added to your financial toolkit. These are the absolute must-know takeaways from our little study guide here. So, what did we learn today? Well, for one, money's value is not static. It's always changing, all thanks to that amazing power of compound interest. We've also unlocked our 2 main time travel tools, the FP factor to see the future and the PF factor to understand the equivalent value in the past. We've proven that these ideas are universal. They scale all the way from a personal bonus to a massive $200 million corporate investment. And maybe best of all, modern tools like Excel put all of this incredible power right at your fingertips. You now get it. You understand the language of financial time travel. You know how to find the future worth of a present amount and the present worth of a future one. So the only question left is, what future will you calculate?